Hello everyone, this is number 18 on the 2020 AMC 8. So we have a geometry problem. So this is actually one of the questions that you will appreciate the Pythagorean triples, okay? So before we get started, we have like half of a circle, and then there's a square inside that's given. And based on that, we are looking for the area of the square. Actually, not a square, that's a rectangle. Okay, so but it looks like a square, which is why, if this is 16, so most people think this might be 16. So the answer choice is actually given as square of 16 as in one answer, but this is not actually the answer. So you want to be careful with that, okay? But here's my general approach. Whenever you are dealing with a circle, go ahead and find the center point of the circle, even though this is a half circle. So just find the center point and connect that point with some intersection. Sometimes like that will be tangency, sometimes some other intersection. So if I connect this center with this or with C, so I could see something going on actually nicer, okay? Since this is my center, I'm gonna label as O. We know this is a diameter of the circle if you just actually fully draw it. So that is 9, 9, and 16. So if you take the half, that will be actually half of the 16 as well, which is basically 8 right here. And this is also 8. So as soon as you see this, we want to find the area, which means I just need a B. So I can see that my radius was from this point to this E, which is 8 plus 9, that's 17. But at the same time, this is also 17 because that's also radius. And this is my right angle. So at this point, you can go ahead and use your Pythagorean theorem to find AB. Or if you remember some of the most useful Pythagorean triples, which is, I'm going to remind one more time, 3, 4, 5, and like 5, 12, 13, 8, 15, 17, right? And then we have 7, 24, 25. So these are the really common ones. So this is 5. Okay. And if you remember like this, and then you can actually get the answer immediately without really using Pythagorean. So that is actually the case. So 17 is the hypotenuse, 8 is one of the lengths. So that means other length should be 15. If you recognize this guy, but if you don't, so just use the Pythagorean. So if I call this is x, so that would be x squared plus 8 squared is 17 squared, right? And if you subtract 8 squared from both sides, so that's going to be 289, which is 17 squared, minus 64. So that will be x squared will be 225. That's actually 15 squared. So which is one of the perfect squares you want to remember, okay? So that's 15. So the other side is 16. So if you multiply those, that will be 260. 240. So 15 times 15 is 225. So, but you multiply 15 by 16, which means one more multiple of 15. So 225 plus 15 is 240, or you can just random multiply, okay? So that is really not too bad. So for a number 18, just like with the center with the intersection, that's basically what you want to do, okay? That's it.